Okay, welcome back, and now we're going to do another example. Here we've got f of x is equal to 5 times x to the 1/3 power minus x to the 5/3 power. And so again, we're going to use the first derivative test and figure out what's going on at the critical value. So we need to find the critical values first. So we take f prime of x, and in this case, f prime of x is going to equal 5/3 x to the negative 2/3 power minus 5/3 x to the yeah, 2/3 power. Okay. And so now I'm going to simplify this even further. So this is going to equal let's do 5/3, and this is going to be 1 over x to the 2/3 power minus 5/3, oops, not 5/5, 5/3 x to the 2/3 power. And now I'm going to keep simplifying. I'm going to try to get this in one fraction. So I'm going to write this as 5 over 3x to the 2/3 power minus 5x to the 2/3 power over 3. So now I'm going to get a common denominator. So I've got a 3 here and a 3 here, so I'm just going to multiply this, the top and the bottom of this fraction, by x to the 2/3. So I'm going to get 5 over 3x to the 2/3 minus 5 x to the 2/3 times x to the 2/3 over 3 times x to the 2/3 power. And so now I'm going to combine them. So I get 5 minus 5. This will become x to the 4/3 power divided by 3x to the 2/3 power. Okay, so now that we've got it set up this way, now we can use the first derivative test. Okay? So we'll set this equal to 0. Okay? Now, I can actually, I can factor out the 5 here. So I will say this will be 1. Yeah, so I can factor out the 5. Now, where is this thing equal to 0? Let's do that one. Remember, critical values occur when the derivative is either 0 or undefined. So this is going to be 0 when the when the numerator is 0. That's only going to happen when x is 1. Actually, -1, 2. It'll happen at -1, 2. Because this is has an even. 4 is even. So x can be negative or positive. So our critical value will be x equals plus or minus 1. And then, of course, where is it undefined? Well, that's going to be when the denominator is 0, and that occurs when x is 0. So another critical point is at 0. Okay? So now we're going to split up our interval. So one interval is going to go from negative infinity to negative 1. And then another interval is going to go from negative 1 to positive 1, right? And then we're going to have another interval from 1 to 0. Oh, hold on. I messed up. So negative 1 to 0, and then from 0 to 1. And then the last interval will go from 1 to positive infinity. Okay? So now, there are the subintervals. So now we're going to basically just start testing points. So we've got this. Okay? So we're going to use this factored form to help determine the sign. So if I choose negative 2, well, negative 2 is going to give us what? So negative 2 to the 4th power is 16. The square root of 6, or the cube root of 16, there isn't one, but it's going to be bigger than 1. And so this is going to be negative. And then of course we got a negative on the top, and since we're using a negative number on the bottom, that's going to be positive, right? So if you square it and then take the cube root, you're going to end up with a positive number down here. So we got a negative divided by positive, so that's going to be negative, right? So now we know that it's negative everywhere. Now we're going to pick a number between negative 1 and 0, and so let's choose a half. If I take a negative half here again is going to become positive, right? So I'm going to get an even smaller number. And if I take the cube root, so I'm going to end up getting a number that's smaller than 1. So that means this whole thing is going to be positive. And of course, I'm going to have a positive over a positive because, again, the same thing. If I square the negative half, I'm going to get positive value. So I'm going to end up with a positive over a positive, which will give me positive for that interval. And so if I now go to the next interval, which is 0 to 1, now I'm going to choose positive a half. Well, if I choose positive half here, I'm going to get the same thing. Right? I'm still going to get the same value here and the same value here, so I'm going to end up with positive again. Okay? And then the last one is, let's pick 2. So if I choose 2 here, well, guess what? I get the same thing that I got over here when I did negative. Okay? I'm going to end up with a positive number over here that's bigger than 1, and I'm going to end up with a positive number. So I'm going to end up with a negative over positive, which is going to give me a negative. And so then I end up with this situation here. So what does it tell me? Well, it's decreasing on this interval and then increasing on this interval, which means at negative 1, so f of negative 1 is going to be what? A it goes from positive and then stays positive. So at 0, it's neither. Max or min. And then f of 1, we go from positive, so increasing function, to negative, which is a decreasing function. So we're going up and then we're going down, which means f of 1 is a local maximum. And that's it. I think that's all they want us to do, right? That's it. Have a great day.